Okay, guys, so we're going to talk about stoichiometry some more, and we're going to talk about kind of a roadmap. And I've posted this onto Plus Portals for you. And it's kind of divided into 3 regions. And I'm just going to put some little lines in here for you. So on this side is what you're given. On this side is what I want you to find. And there's several places where you can start. And connecting the two is always your balanced equation. And that's why we did the last chapter, was to make sure we know how to balance equations. And you may be given them to you in words, but this is always what's going to relate your moles of given to your moles of what you want to find. And that could be 2 reactants, 2 products, a reactant and a product. It makes no difference where it is on the equation. So let's focus on this given side first. I could give you particles, I could give you grams, or I could give you liters. Well, and the fourth thing I could do is just give you moles. And depending on where you're starting, that will tell you how many conversion factors you need and where you're ending. So if you're starting out here at the very left side, you're going to need a conversion to get you to moles, and that would be your first conversion. So if you're going from particles to moles, you would use Avogadro's number. If you're given grams to go to moles, you would use molar mass. If you've given liters, then you would use the 22.4 liters equals 1 mole of STP. And I will never give you anything but STP to go to moles. Then once you're in moles of what you're given, you use the balanced equation to get you to moles of what you want to find. Once you're here, you need to then look at your problem again and see, am I done just finding moles? If not, then you'll need, again, another conversion to get you to the final answer. So you will always need at least this one conversion in the balanced equation. But you could need up to 2 more, or a total of 3, to get from where you're given to what you want to find. So with all that being said, other piece of information you'll need, of course, would be the problems, but you would also need your periodic table in case you're given grams. So let's look at an example problem real quick. And we're going to start here with just something real simple. So here's the balanced equation. And it says, how many moles of oxygen will be formed from 1.65 moles of KClO? So what I'm given is going to be 1.65 moles KClO3. What I want to find is moles of O2. Since they're both moles, and looking here, I see here's moles and here's moles. I just need one conversion factor. So going here, I'm going to start with whatever I'm given. And now for my balanced equation, I'm going to put in the moles here. Since this is KClO3 here, then I put the coefficient in front of KClO3 here. So this would be a 2, and this would be a 3. And so in my calculator, I would put in 1.65 times 3 divided by 2 equals, and I get 2.475. But I have to then look at my significant figures, and I have 3 here, so I can only have 3 here. So that 7 is going to round up to be I can't even write this morning. 2.48 moles of O2 is your final answer. Okay. Now I'm going to skip over some more of these moles because those are pretty simple. Let's look at here. Oh, and again, this is just going from moles to moles. So again, too easy for you guys. So moles and moles. Okay. So let's look at some more problems, and these are a little more difficult because they will have a few more spots we have to fill in. And so here's an example. Again, we have the balanced chemical equation. It says how many grams of O2 will be formed when 3.75 grams of KClO3 are used. So we always start with what we're given, and it goes here. This number came from the periodic table, and this is the grams for 1 mole, or the molar mass. So you would take potassium plus chlorine times 3 times oxygen. That's how you get this number. Then where are we going to get this number from is this mole-to-mole relationship. And again, they're relating KClO3, so our 2 would go down here, and our 3 would go up here. And then we have to think about the formula for oxygen. When we look at oxygen on the periodic table, it says 16.00. But that's just for one oxygen atom. Oxygen is diatomic, so I would have to take the molar mass of 16.00 times 2. You notice here it only comes up with 32, but I see those 2 zeros, so I need to make sure that I add those. So this is 1 mole for 32.00 grams. Now that I've got everything filled out, I'm ready to go into my calculator. I'm going to put 3.76, and I'm going to divide by 122.55. And you can multiply or divide in either order. I think I'll divide first this time. Divided by 2, and then times 3. And then I don't have to do anything with 1, so then it'd be times 32.00 equals. And I get here 1.472. You notice I didn't change that 2 at all. I have 3 significant digits here, so I need 3 in my answer. So my final answer here is going to be 1.47 grams of O2. Because that 2 tells me the 7 just rounds off. Okay, so this is about as complicated as it can get. Like I said, you can either be given, if you start with, and let's get back our flow diagram. I could give you moles and ask you to go to moles, 1 conversion factor. And so you might want to write these down as I go through them. If I go to moles of given to grams of find, now I'm going to need 2 conversion factors. If I start with grams and end in moles, I would need 2 conversion factors. And so each arrow that you go over is a conversion factor. And so that's why this chart will be very helpful, because you can say, okay, I'm here, I'm going to need 1, 2, 3 conversion factors if I want to go here. So I hope this helps. You should begin working on your practice problems. They are due on, let's see, when are they due? Thursday, the first section. So I'd like to be able to get questions from you if you're having problems, so you can ask me between now and then. And I'm happy to post extra videos at any time. You just have to ask. Okay, so have a great day.